Imagine a starry night sky. You look up and see a scattering of points, familiar constellations, the Milky Way, maybe one or two planets. But behind this thin pattern of twinkling lights lies a structure that the human brain literally cannot grasp in its entirety. What we call the edge of the universe is one of the most insane ideas our species has ever conceived. This is not a line in the void beyond which nothing exists. This is the boundary of our vision. The edge not of the universe itself, but of the bubble within which we can actually see and measure anything. And this bubble is not a metaphor. It is the physical reality of our telescopes and satellites. The observable universe. Our bubble in infinity. If you imagine us at the center of a perfect sphere, then in all directions stretches the observable universe. A bubble with a radius of approximately 46 billion light years, not 13.8, as the age of the universe according to CMB, but exactly around 46 billion. The full diameter is about 93 billion light years. These are not just big numbers. These are distances that don't fit into consciousness. To grasp the scale, imagine. Light circles Earth 7.5 times per second. In a year, 1 light year. If you could fly at the speed of light continuously for 13.8 billion years, you'd only see part of the bubble. But the real edge is 3 to 4 times farther. Why this happened, we'll unpack shortly. The entire history of stars, galaxies, nebulae that we can possibly observe is contained within this bubble. At the center, us as observers. Not because the universe revolves around us in a geocentric sense, but because any point from which someone looks outward will be the center of its own bubble. Every mind in space draws such a perfect sphere of ancient light around itself. Beyond, not a black wall and not the end of matter. It's simply light that hasn't had time to reach us due to speed limits, or already so distorted by the expansion of space that our instruments can't register it. This is the event horizon for an observer. Why is the sky black? If space is full of light, Olber's paradox sounds simple and logical. If space is infinite and contains infinitely many stars evenly distributed, then in any direction, your gaze will eventually hit the surface of some star. Therefore, the sky should shine like a daytime dome, but it's black. Why? The answer lies in the physics of light and the evolution of space itself. Light stretches with time and distance. Light is an electromagnetic wave. Imagine ripples on water from a thrown stone. First frequent and bright, further out, they stretch, amplitude drops, waves become almost imperceptible. The same happens to photons in expanding space. Redshift. As the universe expands, light from distant objects stretches. Its wavelength lengthens. It redshifts and leaves the visible range into infrared, then even deeper into microwaves. Our eyes perceive only a narrow strip of the spectrum, from red to violet. Everything stretched beyond that is simply darkness to us. Age of light. We see distant galaxies not as they are now, but as they were billions of years ago. Their current state is inaccessible to us. Light from there is still traveling, and the light we see has already been greatly weakened and stretched. What we perceive as black sky is actually filled with ancient, weakened light that we simply don't know how to perceive directly. Our eyes are not a universal tool, but a narrowly specialized sensor for Earth's daytime world. Wall of ancient light, cosmic microwave background. If we crank up the sensitivity to the limit, we discover that cosmic darkness is permeated with the faintest but absolutely ubiquitous afterglow: microwaves. This is the cosmic microwave background, CMB, cosmic microwave background, the oldest light that exists in the universe. It was born when the universe was just about 380,000 years old, and since then has been traveling through space, continuously stretching along with its expansion. Our bubble of the observable universe rests precisely against this afterglow. Visualizing CMB, we get a map of very weak temperature fluctuations, thousandths of a degree. It looks like a mottled thermal sphere surrounding us evenly from all sides. These tiny plasma density fluctuations are the seeds of future structures, where slightly denser galaxies and their clusters will form billions of years later, where thinner cosmic voids will remain, huge gaps between clusters. From the spectrum of this microwave background, we can recover the age of the universe, about 13.8 billion years. But the distance to the edge of the bubble is 46 plus billion light years. How did 13.8 billion year old light get so far? The answer is simple yet breaks familiar intuition. Light didn't break the speed limit. Space did. The speed of light is a limit for motion through space, but space itself plays by different rules. Here we need Einstein and general relativity. In Einstein's time, early 20th century, most scientists imagined the universe as a static, unchanging sea of stars. Problem: those same equations of general relativity predict that under gravity everything should collapse into a single point. To save the static universe, Einstein introduced the cosmological constant, artificial anti-gravity that would balance the attraction of all masses. Then came Edwin Hubble's observations in the 1920s. Galaxies. What was thought to be nebulae in the Milky Way turned out to be separate galaxies beyond its bounds. For example, famous Andromeda is not a gas cloud, but an entire galaxy 220,000 light years across, 2.5 million light years from us. Redshift. Light from these galaxies was shifted toward the long wave part of the spectrum. The farther the object, the stronger the shift. Galaxies aren't just receding. Space between us and them is stretching. Hubble's law. Recession speed is proportional to distance. Nearby galaxies crawl slowly, distant ones race away at enormous speeds. The universe expands, not from a center, but evenly at all points. Conclusion: the universe is not static, it expands. And not just expands, but does so with acceleration, due to that very anti-gravity, now called dark energy. It makes up about 68% of the universe's total energy and drives the accelerated stretching of space. Key detail: no object flies through space faster than light. But the distance between two distant points can increase faster than light speed if the space between them expands. That's why light that began its journey 13.8 billion years ago can now be 40 plus billion light years away from us. It traveled at constant 300,000 kilometers all that time. But the floor beneath it kept stretching. The Big Bang. That didn't bang the school picture of a cosmic egg that exploded into emptiness and flew apart in all directions is convenient for explaining to children, but fundamentally wrong. The universe didn't scatter from one point into some external space. Space itself emerged with the Big Bang, and the entire cosmos began expanding everywhere, at all its points simultaneously. To understand the scale, we need the inflation model. Pre-inflation was some initial state of space. Very dense, very hot, nearly uniform, but not an infinitely small point in the usual sense. Size unknown, but finite. Inflationary expansion lasted a negligible time, about 10 to 32 seconds. In that time, a tiny volume grew to cosmic scales, like if an atom-sized region inflated to solar system size. Expansion factor, at least 10 to 26 times. This happened not with one point. Inflation engulfed all space at once. If the initial state was sand grain sized, after inflation each grain became galaxy sized, and there were infinitely many such grains. We see only a small fragment of this structure, our observable universe bubble. What's beyond, we can only model, continuation of similar structures with comparable physical laws, geometry distortion at very large scales, and possibly entirely different bubbles with other fundamental constant parameters. What the edge of the universe means for us. Putting it all together, the picture becomes paradoxical and philosophically rich. We live at the center of a spherical observable cosmos bubble with a 46 billion light-year radius. This center is subjective. Any observer in any galaxy will draw the same sphere around itself. This bubble is bounded by a wall of ancient light, microwave background, not because there's physically nothing beyond, but because we cannot look deeper in time. No information could reach us from beyond the event horizon set by light speed. Space itself beyond the bubble continues, possibly infinitely. But from physics and observation standpoints, it doesn't exist for us yet. Not nothing, but simply inaccessible, outside our causally connected world. As expansion accelerates under dark energy, more and more galaxies fall out beyond our causal horizon. Their light stops reaching us. In the distant future, trillions of years, remote clusters will disappear from view. Their photons will never reach the Milky Way again. From inside, the universe will look much lonelier and emptier. Just our local galaxy group slowly merging into an elliptical galaxy, and absolute darkness in all directions. Humanity at the center of its own bubble. Perhaps the strangest and most poetic thought, you really are at the center of the universe. Your observable one. Not in the absolute, but in a physically correct sense. Every rational observer anywhere in space will draw the same perfect CMB sphere around itself. And in each such sphere, the center is precisely the one looking. On one hand, this returns us to very ancient intuition. The world revolves around me. On the other, radically nullifies it because there are infinitely many such centers, each subjective. The edge of the universe is not a physical wall, but a fundamental limit of knowledge, an event horizon for the observer set by light speed and space expansion. We can measure its boundaries with thousandths of a degree precision, but cross them, never. This is simultaneously both limitation and gift. Limitation, because absolute knowledge completeness is unattainable. Gift, because in this limitation meaning is born. Each bubble, each event horizon is someone's unique perspective on the cosmos, each valuable in its own way. The cosmos doesn't end beyond the horizon. It simply awaits new eyes that can see it from their side.